so the strategies when it comes to these more complicated ones are as follows. First, you determine the different cases. You look for the words like and, /or, /at least, /at most, etc. Then, you determine the number of permutations for each case. So once you've determined the number of different cases for each case, calculate the permutations. Then once you've got the separate individual permutations, you add those permutations together. So Tanya needs to create a password that can use digits from 0 to 9 and /or. So I'm going to highlight that in green because those are the key words that we're looking for when we're trying to distinguish whether there are multiple permutations of the alphabet. The password is case sensitive, so that's a key thing to know because that doubles the amount of letters we can use, and must be at least 5 characters to a maximum of 7 characters, and each character can only be used once in the password. How many different passwords are possible? So the first thing that we're doing here is I note that there are 52 letters because the case sensitive portion doubles the 26 of the alphabet. And then when it comes to digits, from 0 to 9, that is 10 digits. So I'm going to write here 10 digits. And so that gives us, if we're thinking about the strategy, that gives us a total of 62 objects or choices. Now, since there are essentially 3 passwords to make, and I'll tell you where I get that idea from, the passwords that you're making has to be at least 5 characters to a maximum of 7 characters, which allows room for a password with 5 characters, a password with 6 characters, and a password with 7 characters. Now, each of these passwords have their own number of permutations. And so for 5 characters, out of 62, you could say sets, right, or digits and letters, we're choosing 5 of them. When it comes to the 6 characters, out of 62, we're choosing 6 of them. And then for the 7 characters, out of 62, we're choosing 7. Now that would complete step 2. And then finally, once I have the permutations or possible ways for each case, then we simply add the cases together. And when you plug this into your calculator, finally, you get 2.52 times 10 to the 12 different passwords. Now, to go all the way back, how did I know this was a permutation in the first place? Well, different is another way of saying unique. So every password has to be unique from each other within each, restriction of character. And so if you don't have order, there's no way to guarantee that they won't be unique from each other. So again, this is one of the cases that it infers order. How many words with at most 3 letters can be formed from the letter tiles Sunday? So the first thing I did was I circled at most because that indicates a multiple case. So that's one of the words. At least, at most, and /or. These are words that signify multiple cases. And then what I've done for the first step is I've identified how many letters and how many cases am I going to deal with? Well, the most letters that you can have in a word with these restrictions is 3. And out of 6, that's going to be 3 cases, and each with its own set of permutations. The first case would be with 1 letter, the second case would be with 2 letters, and the third case would be with 3 letters. And if I'm looking at the permutations, out of 6 letters, I'm choosing 1 for the 1 letter. Then out of 6 letters, I'm choosing 2 for the 2 letters. And out of 6 letters, we're choosing 3. And just plugging in these numbers into our calculator, we get an answer of 156. And that's how many words you can make with at most 3 letters. Now, if I were to break each one of these down, well, 6 choose 1, if we're looking at the permutation formula, breaks down into this. And then if I look at the other one, it would be as follows: 6 minus 2 factorial. And then same thing over here. Let me write that a little bit better. I would translate this to 6 minus 3 and then factorial. And if I were to get these values separately, well, this one over here would be 6. This one over here would be 30. And this one over here amounts to 120. And so if we go 6 plus 30 plus 120, as we already know, that gives us 156. Now, what gave this away in general, that this was a permutation, and I always like to go back that because it is important to be able to understand or recognize when you're looking at a permutation problem. Well, the nature of forming a word demands order. Because if order is not important, if you don't care how letters are arranged, then there's no guarantee that you can make a word. So just the word in its nature demands an order of letters. So in this last one, which is a little bit tricky here, it says how many 3-digit odd numbers greater than 600 can be formed using the digits 2, 3, 4, 5, 6, and 7 if a number contains no repeating digits. And so one of the key words that does give it away would be the and over here. Now, when we list all the numbers like this, the only ones that we're interested in are the 3, the 5, and the 7, with regards to odd numbers that you could choose. Now, the reason why this brings 3 cases alone is because what makes a number ultimately odd is what it ends with. And so if you have 3 odd numbers, that means that it could end as an odd number 3 different ways. Now, that being said, if there was a 4th number, odd number to choose from, then there would be a 4th case, because now there are 4 possible sets of how this number could end up as odd. Now, what makes this question in particularly difficult is that because all it has to be is greater than 600, the first number in each of these sets, or each of these 3-digit odd number sets, could start with a 6 or a 7. And both of those would qualify as, well, a number that is greater than 600. So that would be 3 cases where there's 3 sets of odd options to choose from, and then 1 case which presents 1 choice between a 6 or 7 that the number starts with. So in total, you got 4 cases or sets. Now, in each case, out of the 3 odd numbers, I'm going to choose 3, and that is going to be the same for all of them. However, in the hidden case, out of 2 numbers, the 6 or the 7, I'm going to choose only 1. And that's what we're going to lead with each time with each case here. So when we plug that in, 3 choose 3 gives us a value of 6. 3 choose 3 again, a value of 6. And then, of course, 3 choose 3, a value of 6, plus 2 choose 1, a value of 2. And this amounts to a total of 20 possible 3-digit odd numbers.